In AP statistics, you will be dealing with outliers off and on throughout your coursework. If you are ever required to verify, justify, prove that you have outliers, you might be directed at using one method or another method. Here we're going to talk about one of the two major methods, and that's going to involve the interquartile range. Now, if you're just commenting on outliers when you're describing a distribution, that's just going to be a visual, hey, this value seems like it's pretty far removed from the rest, seems like it does not belong, this seems like it's visually an outlier. There's a difference between proving, verifying, confirming that you have outliers, and visually saying yes or no, we have or we don't have outliers. Now, the interquartile range method that we're going to discuss here is going to start by you finding the interquartile range for the data set. So you're going to have to determine the upper quartile's value, the lower quartile's value, subtract the two to determine that interquartile range. Next, you're going to determine your upper and lower boundaries for outliers. Your upper boundary is going to be established by taking what your upper quartile is, so quartile 3, and moving past that, above that, by 1.5 times that interquartile range. You're going to determine your lower boundary for outliers by going to the lower quartile and moving that same distance, 1.5 times the interquartile range, below the lower quartile. So how do you use this? So here we have a data set just representing 10 quiz scores. I've got the data in order. Now, if you didn't have the data in order, you have access to a graphing calculator in your AP Stats coursework. You might use the calculator after entering the data to find the quartiles. That's definitely fine. I did this one by hand, so I've already got the data in order. I've only got 10 quiz scores, so I know the median is going to sit between the first 5 and then the final 5 quiz scores. So my divider that cuts the data into 2 halves is going to be between the 77 and the 81. My lower quartile is going to be the median of the lower half of the data. So if I count in 2 on the low end, count 2 from that midpoint, I get my lower quartile in this case to be 72. Using a similar strategy to find the upper quartile on the higher end of the data set, counting in toward the middle value there gives us 84. We need the interquartile range, so I need to take the upper quartile and subtract off the value of the lower quartile. So 84 minus 72 gives you a result of 12. So what is my upper boundary for outliers going to be? Well, I'm going to move past Q3, past my upper quartile, by 1.5 times my interquartile range. So I'm moving up past 84 by 1.5 times my interquartile range. 1.5 times 12 is 18. Moving 18 past the upper quartile gives us an upper boundary for outliers of 102. My lower boundary I find by moving to Q1, lower quartile, and going down by 18, down by that same amount, 1.5 times the interquartile range. So I've shown my work here to establish both the upper and lower boundaries for outliers, and now I need to develop my conclusion. So we don't have any values on the upper end of the data that exceed 102, so we do not have any values that qualify as outliers on the upper end of this data set, but clearly 49 is below 54. So because 49 is below that lower boundary for outliers, 49 would qualify as an outlier within this set of quiz scores. Now I have a couple modified versions of this example that we'll talk about. So we'll click ahead, but this is kind of the standard way that you would use this. Just to talk about a couple other things that you might encounter. So if you notice, I have the same data set, except I changed the second to last value. I believe it was previously a 68. Changed that second to last value, that second lowest value, down to a 50. My quartiles don't change, therefore my boundaries for outliers don't change. I now have 2 outliers on the lower end. So I wanted to make this comment because I've seen students in the past assume that, well, because 49 and 50 are close together, I'm not going to have any outliers. There aren't any values that are really far removed from the rest. Well, in this case, based on this test, both of those values would qualify as outliers. Again, if you were asked to prove, verify, confirm, justify whether you have outliers, you're going to want to go through this process that we're illustrating right now. One more quick modification to the data. What I'm going to do in this last modification is I'm going to change this 83 and this 84 to an 81, and I'm going to adjust this back to a 68. So you see that modification has been made. Now, when I have 81 showing up in this set of quiz scores 3 separate times, that actually changes my upper quartile from 83 or 84, I think it was previously, down to an 81. So we do have to modify the work that we did from a few screens ago since our upper quartile has now changed. Our interquartile range is now 81 minus 72. Pretty small interquartile range, only 9 units. I'm going to establish a new upper boundary for outliers. I'm going to move 1.5 times that interquartile range past the upper quartile. My lower boundary is going to be established the same way we talked about earlier, going down 1.5 times that interquartile range from the lower quartile. I have my upper boundary, I have my lower boundary. In this case, we have both an outlier on the low end and an outlier on the upper end of the data.